but here we are in Blackboard Collaborate. Okay, and I'm recording. So again, this is IDS 200 for those of you joining us late. We're a little packed in here, so, you know, it is what it is. And today we'll be going over the syllabus and a quick lecture introducing the topic of management information systems. All right, so let's go straight from the start. Who am I? I'm Doug Lundquist. I'm the instructor. I'm a UIC alum, which is why I have a UIC student email. So, you know, don't think that they're like pushing off some, you know, undergrad student on you to teach this course. I am actually, you know, graduate. I got my bachelor's here in finance and then rolled into a PhD program, got that in MIS, and then I've been faculty for a little, you know, full faculty for a little over 10 years. I don't know how you clarify full faculty. I've been an instructor and not just a postdoc. So anyway, I've been doing this for a while. This course in particular, we did a transition about 6 years ago. We had a pretty standard MIS course, and the thing with that is, you know, it was a standard one with a big expensive textbook and covered like, you know, 50 topics in 20 weeks. And it covered the material, but the students were kind of bored with it. They're like, yeah, this, you know, this is stuff, this is MIS, sure, but it's boring, and they didn't get into it. And so they brought me in to try to revise the course, and I said, yeah, okay, I'll do it. And so what I did a different thing, where what we do is we look at all the systems and technologies that these big online companies use. So we'll look at Facebook, we'll look at Amazon, Google, YouTube. We'll cover a lot of the same ground that an typical MIS course would. You know, we'll talk about databases, we'll talk about quality of service issues, we'll talk about, you know, analytics of various kinds. But the focus is what I try to do. I try to bring in things that you're already familiar with. You know, even if you're not all on Facebook, I'm sure everybody is familiar with Facebook. You know, everybody's familiar with Amazon, Google, YouTube. So hopefully we have something there that we can start with. Okay, there is a course schedule at the end of the syllabus if you're wondering about what's coming up, but it's at the end of the syllabus, so we'll get to it eventually. There's no textbook, so you're welcome. Okay, I remember when I was an undergrad many years ago, I had some sticker shock when my semester bill for textbooks turned out to be $800, and I was like, what the fuck? So, and so I figured pretty much all my courses, I don't use textbooks. Because why? Because it's a lot of money. The downside of that, of course, is it puts more on you to pay attention and learn the material, right? It's harder to skip lecture and say, well, yeah, I'll skip lecture, but I'll just read the chapter. So that's the trade-off. But anyway, be that as it may, there's no textbook. Now, what I have done this semester, because everybody's kind of checked out, I mean, you know, the world is still recovering from COVID, even though people think we're all good. We're really not. You know, everything's still pretty fucked up. And so what I've done is I've started including notes for the lecture. So for the first, you know, lecture we'll do, that'll be included on the exam is this Facebook photo management. And there's a notes document here, okay? This notes document is a very simple one-page intro to the topic. Please read it before lecture, because then you won't be hearing all this stuff for the first time, right? It's like a little talk about, hey, here's what the lecture is about, here's the basic concepts. And then when I actually go into more detail in the lecture, you'll understand it, all right? So I'll put it in big red writing right now. These notes are not a substitute for showing up for lecture and paying attention and studying and all that, right? If you just look at this the morning of the exam, you will probably not do that well. Just saying. Okay, but it's designed to help. Okay, back to the syllabus. By the way, we're not super formal here, so if you got any questions, you know, feel free to shout out. You can raise your hand. But, you know, my glasses tend to slide down and my peripheral vision is not the best. You know, I'm not usually looking off to the side all the time, so people might be waving and I might just not see you. So I'm not ignoring anybody on purpose. It's just, you know, I tend to be like really focused on whatever I'm doing. Okay, there's also some software for this, but it's all free. You don't have to buy anything. So if you were worried that you were going to have to buy anything or that you didn't have already bought the stuff you were going to need to have bought, we're all good, okay? So there's that. We use Microsoft Office. It's freely available. It's on the lab machines. You can get it from UIC. You don't have to pay money for it. Okay, and we use Blackboard. So hopefully everybody's familiar with Blackboard. I've seen that high schools are using it now. Everybody used Blackboard in high school for stuff now? Many of you did? Some of you? Some of you, yeah, okay. Yeah, Blackboard's a thing. So hopefully everybody's okay with Blackboard. If you're not, you know, I don't know, you can arrange for a tutorial or something. You can ask me specific questions. The only thing that really might stick you is that every professor has their setup being a little bit different, right? Some guys use a specific link for the syllabus. For me, everything I do is in a course content folder. So I make this folder called course content. You go there, everything's going to be there. Syllabus, lectures, resources, whatever. There's a link for announcements because announcements sometimes happen. There's a link for Blackboard Collaborate, but that's it. I try not to have it be too cluttered, right? These are the only things you're going to see. All right, why do I have two links for this? Ugh, bastard, go away. Okay. Email. So I don't know if you know the state of professors. What happens a lot at a big research university like UIC, and UIC is like a very big research university, what usually happens, most of the professors are what is called on tenure track, and their main job is to do research. They do a little teaching, sure, because they kind of have to, but their main job is doing research, right? So they might have one class with like 30 students, and the other 38, 40 hours a week, they research. I'm the opposite. I pretty much do no research at all, although I did put out a paper last year. I mostly just teach. This semester I have 5 courses, and I'm helping with a 6th because one of our instructors bailed, and I have to, you know, basically help out the new guy. So I teach a lot. And because I teach a lot, number one, I teach a lot of different sections, okay? And number two, I have a lot of students. I have like something around 400, 500 students this semester. I didn't actually do a count, but I got a bunch. I got a bunch of students. So this means a couple things. Number one, if you email me, I'll try to get back to you quickly. You know, some of you are probably here, probably have already emailed, and I did get back quickly, but sometimes I get a lot of email, and I'm caught between things. I got kids at home, and I got work stuff, and sometimes there's just a flood of email because like multiple courses having exams. So I might get backlogged a bit. I might be a little slow to respond. I might occasionally miss an email just, you know, due to the sheer volume of communications, you know. It does happen. It's rare, but it happens. So anyway, if you don't hear from me within 48 hours, you know, give me a little time to respond. But if you don't hear from me right away, then by all means say, hey, you know, I sent this earlier, you didn't respond, I'm following up. And I'll be like, oh shit, sorry, you know, something went wrong there. Okay, of course, you know, common sense applies, again, specifically because I have 400 students. If I had 30 students and you emailed me like shortly before an assignment was due, I might be like, yeah, okay, I'm not doing anything, I'll take 5 minutes to respond. But you gotta understand, if it's Friday night and I got 400 students and 200 of them have an assignment due and a bunch of them are asking me questions on Friday night, I'm gonna be like, should have asked me during the day. I'm not spending my Friday night responding to email, okay? Yeah, what's up? Oh, you're just waving a bottle at me. Okay, so common sense applies, right? Also, if you email me, please include at least the course name, you know, in the subject line somewhere in the email. Say, you know, you don't need to include your name because I'll see that at the end of the email, you're right? But you'd be like, I'm a student from your 9:30 a.m. IDS 200 and I have a question about this. And then I'll know what section you're in, right? Because if you're not, otherwise I'll have to do some back and forth, right? Because I got a bunch of courses, they have exams, they have homeworks, and if you're like, hey, when is our homework due? What's going to be on the exam? And I'll be like, well, it depends, you know, what course are you taking? And so we'll waste time doing that. So if you want to get a faster, better, more useful response, please include the course number, right? The course, because I got a lot of courses. Okay. Attendance. I don't track attendance. Right, number one, I don't personally believe in coercive attendance policies. I mean, of course, I recommend people come to class, but you're all adults, and, you know, if you want to half-ass your way through college, that's none of my business, really. I mean, I wish you well. Some people do a better job of half-assing college and their whole lives generally than others. People find the need to use their whole ass. Whatever, okay? But attendance, I don't track it. It would waste time from lectures. Don't want to do that. The one exception is, of course, exam days, right? Because again, I got 400 students. If I got a bunch of people that are missing exams just, you know, because, well, that, you know, materially inconveniences me. and I will not be pleased about it. So I know sometimes shit happens, you know, like if you get in a car wreck on the way down to campus and you take pictures of your car, or, you know, you get hit by a bus or something, I will understand. But just saying, you know, if you don't have a good reason, then yeah, I am prone to impose penalties. So, big thing, general rule, if you have scheduled the reason yourself, it's not going to be considered a valid absence, right? So things that are fine, medical emergencies, right? You get a appendicitis, yeah, go to the hospital to get that taken care of, right? It's more important than the exam. If you're in UIC athletics, I got at least one letter about that. I'm sure there will be more this semester. If anybody's like National Guard or you know, Army Reserve, something like that, and you got to do something, because I have had students have to take like 2 weeks out to do that. Anyway, court dates, you know, I'm sure you all are innocent, but just in case you got to go to court for something, right? Stuff like that, yeah, okay, we'll work around it. But if you scheduled it yourself, like say, well, I scheduled, you know, an appointment with the dentist to get my teeth cleaned, then yeah, no. Check out the syllabus, see when the dates are. Don't schedule trivial shit over the exam times. Okay. And last thing, students with disabilities, if you have a documented learning disabilities, you can get some reasonable accommodations with our Disability Resource Center, the DRC, for things like extra time or a quiet room to take exams in, so you have, you know, a fair shot at doing well in the course. All right, that's the big stuff. That's section 1. That's the course policies. Questions about any of that? All pretty sensible, I hope. Okay. So, like I said, please come to lecture. But if you don't, that's your business. Now, grading. We have a strange parallel system for this course. Some people like it, some people don't, but I guess it doesn't really matter that much because it just is what it is. So I'm going to talk about that. Bum, bum, bum. So, oh, people still rolling in. This is nice. Okay. Don't be shy. Come in and have a seat. Come on, you. What font shall we use? Ooh, Broadway. That's exciting. Ooh, Century School Book. That's so old-timey. Okay, we'll go with that. Okay, so lab is one part of the course. Lecture is another part of the course, okay? And there we go. The lab total is 300 points, okay? 300 points from homework, from lab exercises and attendance, right? Because when there are lab sessions, there'll be an exercise you go through and you turn it in more or less at the end of lab. So attendance is required, but you got to turn in the work as well. There's that, and I guess that's it. I'm thinking. I feel like there's something else, but nothing's ringing a bell, so yeah, I guess that's it. Okay, so that's that, right? That's the lab stuff. Oh yeah, pack. I'll talk about pack is kind of, I guess that's more on the lecture side. So on the lecture side, there are 700 points. And that comes from a few things. Pack, which is online Q&A platform. And last I checked, it costs 29 bucks. So it kind of sucks, but the nice thing about pack is, number one, some students like it. So I'll go with that. It can lead to some interesting conversations. You know, if you consider that to be the textbook, that is a very cheap textbook for 29 bucks these days. And it is not, there's an opportunity for extra credit for doing that. So you can do a little bit more than the, you know, requirements, and you get extra points. We'll talk more about that closer to the date. Pack won't open until week 3, so that'll start happening in a couple weeks. The other is exams. 4 exams at 150 points each. Okay, now if you have heard that this course is difficult, it's almost metaphysically certain that the difficult part is the exams. So the exams are multiple choice, but they're challenging multiple choice. It's not just match this term with this definition, right? There's a whole, there's more detail in that, and I'll get into it closer to the thing. But trust me when I say these, you know, multiple choice exams, even though they're multiple choice, they are challenging, and please don't take it as a personal challenge to try to do as well as possible without studying at all. Okay, so, and that's it. Now, what we cover in lab, first, MS Access, right? That's a database software. MS for Microsoft, and then MS Excel, which is spreadsheet software. And I know many of you will have already used Excel, right? Typically, numbers are about 70% that we see most of the time. People have at least, used it. And then we'll have a little bit of web design, right? So HTML, CSS, JavaScript. Okay, so we'll do a little bit of web page type stuff towards the end of the course. The lectures, again, we have 4 modules. Facebook, there's a module, Amazon, Google, and finally YouTube. Okay? And each one of those is about 4 weeks. The final exam for the YouTube session, there's 3 weeks of lectures, and then the 4th week for YouTube, we have the final, so the end of the course. So that's pretty much the structure. Now, there's not a whole lot of tie-in between these two. So one of the comments that I always see at the end of the semester with the student feedback is like, it was a problem that, the labs were not really closely connected with the lectures. But if you think about it, that's really hard to do in this kind of course. I mean, I could make a whole course around Access and Excel, right? If this were a database course like IDS 410, yeah, I could do a whole bunch of stuff with Access. If this were a spreadsheet course like what? Like IDS 331, right? Basically advanced Excel stuff, macros and things, yeah, I could make a course around that. But the course is just to introduce you to these so you have a little bit of experience with Excel when you go off and do other business courses. Or if you do something with databases, like especially if you're an IDS major, you have some exposure to that. Likewise, if I'm going to keep the lectures topical and relevant, there's not going to be a whole lot of crossover between Facebook and Access. Access is like database software for small business operations. Like if you were running a dentist's office, Access would probably be a good choice for that because it's, it works well enough when it's small and it's cheap and affordable. You don't need some super powerful cloud system to run a dentist's office. But Facebook isn't going to use Access. Access is nowhere near the scale of software that Facebook needs. So it's really tough to bring them in together. And, it is what it is. So the lecture and lab, they are separate. There are a couple of things that come in as far as connections. Like early on in the Facebook module, I do talk about databases because that's, pretty central to the course. And so I'll talk a little bit about it in the abstract in the Facebook lectures, and then shortly afterward, you'll see it in the lab. So there is that connection. Likewise, with YouTube, I start talking a little bit, about internet stuff, more in the YouTube lecture. And so, yeah, there's a weak tie towards the end. Again, if you're going to talk about web pages and things like that, then yeah, you can talk a little bit about building them. But that's about as connected as the things get. Okay, so just be aware. The lecture is one thing, the lab is another thing. They bundle them together in the same course, and it's worth 4 credit hours. Okay. So there is a grading scale. This is like your guaranteed stuff. There will almost certainly be a curve at the end of the course. But it's the nature of the curves that I don't know what the curve is going to be until all the grades are in. All right. But the typical distribution we see around is something like 20-25% A's, maybe 45% or so B's, a chunk of C's like 20-25%, and then some other people who don't do so well. But I'm going to crank out some numbers here, and I'm going to show you that there is no reason why anyone should ever get less than a C if they're showing up and doing the stuff. Okay. So just to relieve people's panic. So suppose you do badly on the exams, like 50% average, right? Which isn't great. Not going to lie, that's not great. So that's 300 of 600 points, okay? But the lab stuff is pretty easy. You have infinite time. You can ask for help. Not infinite time, but you got a lot of time to work on these lab things. And honestly, they're not intended to, be these super complicated puzzles. It's just, can you go in and try to do this and do a good job of it? So most people, and lab attendance is guaranteed, right? If you show up for lab and do the exercise, even if there's a little mistake here or there in the exercise, as long as you show up and do it, you'll get the full points. All right, so there's really no reason why anybody should get less than, say, 240 points on lab. All right? because, you know, there's 72 points for the lab exercises. For the rest, I'm giving you like 170 out of 228, which is something like 80%. Everybody ought to be able to do that well, and people do, right? The average for lab is pretty high. Then, come in. Oh, all right. Anyway, then packback. Packback is guaranteed points if you take the time to do it properly. All right, so it's an online Q&A platform. You type in some questions, and it tells you, it tells you whether they think the question or answer is good enough. Okay, and if it isn't, you have the opportunity to revise it, so you can make it better. And again, if you do the time and you do it correctly, there's no reason why you should get less than 100 points. So, and there's an opportunity for extra credit, but you don't even have to do the extra credit, right? So I'm going to say 100 points there. All right, the total, if we do all the math, 640 points. Okay, and 640 points is typically the lower cutoff for a C. Okay, and it's easy to do better than that, but I'm just saying, even if you're doing badly on the exams, getting 50%, and you're not doing great on the lab, but you're doing good enough, 240 out of 300, you know, is exactly crushing it, and you do the packback, there's no reason why you shouldn't get a C, at least, okay? So don't panic. I mean, try to do well, sure, but, you know, typically for like the first exam often has an average around 65% because the exams are intended to be difficult. Reason why? Right? Lab basically tests, can you show up and can you do the work given basically infinite time and resources? Yeah, that's nice, but, you know, it's good that you do it, but it doesn't really test that much what you know. Same thing for packback is, right, can you show up and do the work given a whole lot of time to do it? But the exams, they're individual, they test what you know. That's what differentiates, you know, mostly tends to differentiate the A's from the B's from the C's, okay? This is how it is. But there's no reason at all for anyone to ever get less than a C if they're showing up and doing all the work. Okay. So there's that, and, you know, again, more details there. I will mention one thing. Life sometimes happens, right? There might be, you know, some homework that's due and you have a confluence of events, or you have some work stuff that comes up, or somebody scores tickets to go see Lady Gaga or something, and you're like, yeah, I'm not going to be getting this homework in on time. If you ask 2 days, please have a seat. If you ask at least 2 days in advance, you can get a 1-day extension on the homework, right? And this basically rewards people who plan their life a little bit better. So, you know, if you wait till the last minute, if you wait till like 10 p.m. Friday for an assignment that's due at midnight, and you ask for the extension, I'm going to be like, sorry, you know, it's just late. But if you ask a couple days in advance, you can see, you know, ahead of time that things are a little busy. Yeah, and if you don't think you're going to be a little busy, you know, again, try to do your homework early. You know, don't wait until 11 p.m. to start the assignment that's due at midnight. Again, yeah, it might end up being late. Okay? But if you ask for an extension, we'll give it to you. And the reason is, right, students typically would not be asking for an extension if they weren't going to try hard to do it themselves. Right? We know that, you know, students do sometimes collaborate in questionable ways, but, you know, if you're asking for an extension, you're probably actually trying to do it yourself. So we'll meet you halfway or a little more on that. Okay. That's that. Questions on any of that stuff? I mean, you can read it for more details, but I don't need to give all the details because you'll fall asleep and forget it immediately afterward. And but it's there. Yes, what? Nothing? Something? Okay. Last thing, section 3, don't cheat. That's all. This is a whole bunch of boilerplate stuff that says, dude, don't cheat. And if you do cheat and we catch it, you know, it's not like we're spending all our time trying to catch people from cheating, because most of the time, most students don't cheat. We know this. But if you, like, make it really obvious and we catch it, like you turn in an assignment with somebody else's name on it, we're going to be like, oh, fuck, you get the 0. Okay? Because, yeah, it is what it is. So, please don't cheat. It is certainly fine to collaborate with other students to ask them, hey, how do you do this? But, you know, don't just lift their file and turn it in yourself. All right? Because those are the things that sometimes get caught. And students, you know, are sad and get 0s. All right. All right, and here's the schedule. There's stuff, you know, as you can see, every 4 weeks there's an exam. So week 4 exam, week 8 exam, week 12 exam, week 16 exam. Okay? All right, any questions about the syllabus? Well, good. So we're right on schedule. I like to take about half an hour to do that. And then, we got this little lecture. So, I shall mention, this is not testable. So this is more, you know, if you don't have any idea what MIS is all about, well, this is where you learn a little bit about what MIS is all about. But like I said, not testable, so no need to take notes. Just, you know, lean back, relax, and enjoy the show. Or something. All right. So, first of all, you might ask, what's an information system? Well, an information system is a mix together of basically automated things, hardware, you know, the machines that do the work, software, the programs they run, human factors like people, you know, the actual workers, and then the procedures they have to follow, and the data they manage. The point of an information system is it stores a bunch of information. You can ask it questions about things. For example, you go to Facebook, right? What happens when you go to Facebook? What's the first thing you see on the screen? Well, I mean, yeah, you would go with the login, sure. Suppose you haven't logged in, right? So you got to enter in your access credentials, right? You got to enter in your username, your email address, and your password. Well, the information system would maintain that information in some sense. It could check that when you enter in a combination of username and password, hey, is this correct? Does this represent an actual user that we have? And if it does, it sends you some access credentials you can use to cruise around Facebook. If not, it says, sorry, please try again. So, information systems. Once you get into Facebook, I was thinking somebody was going to say the feed, right? You go into Facebook, boom, there's the feed there, all the shit your friends have been doing and all the ads Facebook wants to show you. Yeah, that's what you see. And again, information system, at Facebook it does a lot of things. First of all, it figures out who you are and what information is accessible to you, who your friends are, what they've posted. It tries to prioritize things in a sense. It tries to show you what it thinks is the most interesting content so you stay on Facebook longer and make more money for Facebook, right? That sort of thing. Information systems, there's lots of different systems that do different things, but the core of it is they store information that is somehow useful. And a management information system, you know, is basically, the idea there was that ordinary workers wouldn't be doing too much as far as information. So think about like an old manufacturing model, like an assembly line factory for making cars, like back in the 60s. You know, you have your white collar guys, and they need to know stuff like how many cars you're making that day, and you know what the QA problems are, and you know what the stocks of inputs to make cars are available. They need to know stuff like that. The workers on the line, they're just, you know, like turning screws or, you know, drilling in bolts or whatever all day long. So the idea was it's management that's using these information systems. But these days, there's people like all down the line, right? You know, entry-level workers can be using these systems too. So even the term management information systems is somewhat outdated. So we just maybe say information systems. But it's still in the course title, so I gotta say, you know, Introduction to Management Information Systems. Anyway, management information systems typically used to perform some specific task or set of related tasks. So like I said, Facebook would have one system for checking passwords and login information generally, have another system for managing the feed, have another system for managing instant messages, right? Another system for managing ads. Large organizations typically have many information systems. Amazon and Facebook and Google, they all have hundreds of different ones. But some typical things that you see in a lot of businesses, even not, you know, the really, really big ones, things like transaction processing, making sure that when people buy something, the whole purchase process goes through correctly, payroll, making sure that workers get paid, inventory management, you know, basically tracking how much stuff you have on hand to make products and scheduling deliveries when you need them. Say, hey, we're running low on tires. We need more tires to make more cars. Schedule a delivery for that. And customer relationship management. So if you've ever looked at something on eBay, for example, and not bought it, and you'll get an email like the next day saying, hey, are you still interested in this thing? Yeah, that's CRM, that's customer relationship management. They try to reach out to you, to see if there's more stuff they can sell to you. Okay, so key takeaway, information systems, they involve machines, they involve people, they're centered around data. Businesses use them for a lot of different and, very sensible purposes. Okay, so one slide course summary. The nature of the world these days is there's a lot of technology that we basically don't understand works, and that's a design feature, right? So imagine if, in order to use a microwave, you had to know how the microwave actually works. Anybody here happen to know how a microwave works? No? I mean, maybe some of you do and don't want to say, but yeah, it's kind of specialized knowledge. I mean, you have an idea that there's microwave radiation goes zzz inside there, but you don't know all the mechanics of how it gets generated. All you got to do is push that popcorn button, right, and you know your bag of popcorn gets cooked correctly. That is user-friendly interface, right? You don't need to know how all the stuff on one side of it works. You just need to know how to make it do what it's supposed to do. Or like, turning on a light switch. That's another user-friendly interface, right? You don't need to know all the details about how the power plant gets electricity to your house or how light bulbs work. You just know, I flip switch, light goes on, okay? So, that's nice for a lot of things, but if you are an IT person, right, if you're thinking about becoming an IDS major, knowing some stuff about what goes on behind the interface is obviously pretty essential. That's basically what your job is, right, to help design those kind of systems behind the interface. Even if you're not an IDS major, right, you might think about becoming a minor, but it's good to have some, basic knowledge of what goes on in these systems, because all of this tech stuff, it's not part of the language of business. Knowing a little bit about technology is about as important as learning how to write was 100 years ago. If you don't know anything about tech at all, right, you don't know how to use Excel, you don't know how to use the internet, you're going to have trouble. And I'm sure everyone here knows how to use the internet. So that, I'm just tossing that out as an example. Okay, so anyway, in this course, we're going to present familiar examples: Facebook, Google, Amazon, YouTube. Not in that order, it should be Facebook, Amazon. We're going to learn some of the technology behind the interface, and I should mention that there's always going to be this trade-off where if the tech is older, somewhat outdated, it's a lot easier to get detailed information about it. That's just the way life is. If it's something that's new, if it's cutting edge, you might find out that that exists, because they'll issue some notification to that effect. They'll have some trade show, or they'll make some notice to investors, but they're not going to tell you all the details of their special sauce. It's only if tech is like 5, 10, 20 years old that they'll say, oh yeah, we'll just lay this all out for you and tell you how everything worked. So I have more information about the tech that's older. It's unfortunate, but that's life. Okay, now the lectures are divided into 4 modules. Each covers 3 aspects of an IT-driven business. Well, the YouTube module has 3 lectures about YouTube, but they're shorter, so there's also a how the internet works lecture. So there's no textbook, like I said, but there are a lot of online. So if I'm talking about stuff and you're like, wow, that's kind of interesting, well, the fortunate thing for you is there's a lot of good links scattered throughout the lecture slides where if you want to learn more about a topic, you can go and learn a little bit more about it. And as noted, attendance is strongly recommended. Note-taking is good. I mean, I'm not super tied to the idea of taking notes, but if you're going to do it, I would say print out the slides in advance and write comments on the slide pages. That makes more. There's no reason to write down what's already in the slides. Every module ends with an exam, and we'll focus on understanding major topics and how they relate to each other. Like I said, there are multiple choice questions. They tend to be detail-oriented. Unlike some courses you may have seen in the past, knowing the terms is necessary but not sufficient to do well, right? This is not the course where there's going to be a glossary at the end of the chapter, you memorize the glossary, you go and do well on the exam, and then after the exam you forget the terms. It is not intended to be that kind of course. So the material as it is pretty simple. It doesn't go too deep into anything, but there's a fair amount of it, and you got to respect the volume of material. Okay, so let me give an example. I want to give an example. Why did my paint go away? Why did I shut that down? That was foolish. Okay. So there's really 4 ways that I write questions for this exam. The first is recognizing terms and definitions. Okay, so I say this is, it's a starting point. So if I give you a term, know what it is. If I say, for example, for Facebook, if I ask you what haystack is, haystack you'll learn in the first lecture is a photo management database system. So if you say Facebook, Facebook is a database, that's correct. If you say Facebook is, or haystack is spreadsheet software, or, a special type of, I don't know, hardware, if it's a special type of server, something else. No, an operating system, it's none of those things, right? It's photo management database system. So that's that. The second one, similarities and differences. So again, in the first lecture, we're going to talk about different types of memory. So for example, the difference between RAM and disk memory. RAM, expensive and fast, disk, cheap and slow, right? We know this stuff, I hope. So, that's a simple thing. So there's other differences too. Disk memory tends to be permanent. RAM is what's called volatile. It goes away when the power goes away. So there are various things, memory is not one, but you should know how things are alike and how they're different. The third one is, well, I'll leave this as, I'll leave it here. System implementations. Basically, how are the things used, right? So something like haystack, for example, photos that are popular, Facebook wants to store on RAM, so they're really quick and easy to grab and deliver to Facebook users. Things that are not as often used, like older pictures, tend to be stored on disk because it's not that important to deliver them that quickly. Facebook still wants to deliver them kind of quickly, but because RAM is expensive, it doesn't make sense to store everything in RAM because Facebook has untold exabytes of data, and an exabyte is a very large amount of data. And having all that in RAM would be crazy expensive. So there'll be questions about, again, system implementations. How is this particular technology used, for this purpose? How are disks used for haystack? How is RAM used for haystack? Things like that. And then the last one, systems changes, right? For example, what would happen to haystack if all the RAM were replaced by solid-state drives, right? What would happen? Well, a couple things. Costs go way up, or no, other way around. Costs go way down, right? Because RAM is more expensive than disk memory. But system response time, very slow. And I would also add possible bottleneck due to inability to process requests in time, right? Basically, your system might get overloaded because RAM could handle, maybe 1 million requests per second. A solid-state drive might be able to handle like 1,000 requests per second, right? But it still carries a lot of data in there, and so there's going to be a lot of requests, for a lot of things stored on that disk. Anyway, so things like that. Again, we haven't covered this photo management lecture, but these are the kind of questions you're going to see. Okay, so as I start lecturing when things get real on Thursday, keep these 4 ideas in mind. If you see a term that you don't recognize, underline it, star it, whatever, know what it is. If you see a group of things that are all mentioned together in a way that it's obvious that they're similar in some ways and different in others, make a note. This is like this way, this is different that way, right? Anytime I talk about the building blocks of a system, then I talk about a system, try to have some idea of how all those things are getting put together. And if I talk about why a system is designed the way it is, you can consider, hey, what happens if you change this factor of it? Okay? So that's what the exams are built around. And again, this is the sort of knowledge that's difficult to fake. This is pretty easy to fake, right? Terms and definitions. If that's all the exam is, and you know that's all the exam is, you don't really need to read much. You just, again, memorize the glossary. But that's not really learning. That's not beneficial, right? There's no business out there that you get hired after graduating from UIC, and they say to you, oh, welcome aboard, this is going to be a great first week for you, here's a list of 50 terms and their definitions, there's going to be a quiz on Friday, and if you get at least 80%, we'll pay you for the week, right? That is not how work is. What work is, you get, some degree of knowledge from UIC, and they'll say, oh, I see you are an IDS major, great, we're going to put you in on this project that's going on, and maybe the first thing you do is they say, hey, I see you just graduated, so you're probably up to date on all this tech stuff. Go out and search. We need to update some hardware, right? We have this component in our system. We need to find a replacement for it. Go look around and see what's a good replacement that, at a reasonable price. And in order to do that, you need to know a whole lot more than just terms and definitions. Okay? So that's what I'm trying to do here. I'm trying to help you along that road. Okay. Questions about any of that? All right. So yeah, that's good. Okay. So one of the difficult things of IT, though, is mentioning IT and fully explaining the concept often requires a whole bunch of other stuff. But if I build everything from the bottom up, if I explain all the components of a thing before I talk about the thing itself, it's going to be super boring, right? So for example, I could talk about cloud computing from the ground up. I could talk about what servers are, what server clusters are, what replication is, what backups are, what load balancing and interfaces and all that. I could talk about all that, but by the time I got around to actually talking about what cloud is, you guys would be gone, right? So I'll try to explain as much as I need to when I need to. What you'll see in the lectures is I'll often, just talk for a slide or two about something in one lecture before I, do a bunch of slides in the next lecture about it. So you've at least heard a little bit about it. Now, there is time built into the schedule for questions. There are always fewer questions than I hope to get. And it always seems to be the same, like 3 or 4 people, even in a room of students, it always seems to be the same 3 or 4 people that are asking questions, even though I know a lot of people have questions. So if you have questions, please do ask. If we start running low on time, we start falling behind our milestones, I'll let you know, that, oh, we'll talk about this later, or email me, or I can post a more, comprehensive answer through Blackboard later. But if you have questions, please ask. But again, what often happens is that people ask questions like a couple slides before things are going to happen in the lecture, and then I'll say, okay, well, for now, push I believe, we'll get to that soon. But if you do have questions, please ask. Encourage that. Okay. So labs, I've talked about the labs. The one thing I haven't mentioned is there is no lab manual. You don't have to buy anything for that. These are all like a bunch of lab exercises. They're all written as walkthroughs. So what will happen is the TA will say, oh, hi, I'm your TA. Welcome to lab exercise, whatever. Please, start up your machine, download the files, start up access, whatever. And then they'll start going through the exercise. So, do this, you'll echo what they do on your own machine. If you get lost a little bit, if you fall behind, again, the exercises are going to be posted up and written as walkthroughs, so you can actually do them independently of the TA if you want. And then you'll be done. Okay, so that's pretty much it. Now again, attendance is graded. You're not going to get full credit for the lab exercise if you don't physically show up in person, and the penalties are pretty significant. So it's a 6 points, right? 6 points for the exercise. If you don't show up, you're down to 2. All right, so there's a big penalty for not showing. And the reason is this. Excuse me. The reason is IDS has an unusually large allocation of TAs. We have all these TAs that exist to teach our labs where people learn about, among other things, Excel in particular, because Excel is useful for all business majors. Now, excuse me. There are interdepartmental battles going on where there are always people from other departments saying, wow, look at how many TAs they have. That'd be nice. We should get some of those TAs. How come we don't have as many TAs as the IDS department? Well, the answer from the IDS department has always been, because we teach these other things that are benefiting all business majors, not just IDS majors. In order to prove that, we have to make sure that there are physically butts in the seats in these lab sessions. If there aren't butts in the seats, then the other departments can legitimately say, oh, but your guys actually aren't teaching to the students, right? So every time it happens, there'll be some student who, doesn't know some basic thing about Excel, like they don't know how to use, the drag thing to do autofill. And, one of the professors will say, oh, you IDS guys, you're not doing your job. And we'll say, well, look, it was there. We track attendance. It's important. If students don't show up, that's not our fault. They took a penalty for it. And if they learned the stuff while they were there and they forgot it, again, that's not really our fault. We're doing our part. Okay, so if you wonder why we're super strict about attendance in labs, there are reasons far beyond the scope of this course that are driving that. Anyway, so the lab work is directly connected to the homework assignment. So after every couple of lab exercises, there will be a homework assignment that's basically built around the concepts you learned during that those lab exercises. But they're not directly connected to exams, except for the things I mentioned earlier, where again, talk a little bit about basic relational databases in the first Facebook lecture, and then you'll kind of see that in real life in the first couple lab exercises. So if you learn the stuff in the lab exercises, then it'll make it a little bit more real when you see the questions on the exam. Okay, we've covered the syllabus, nothing to say there. Facebook, this is just to give you an idea of the topics we're going to cover. So for example, for photo management, we're going to cover different memory types, storage and retrieval concerns, how Facebook stores data, how they retrieve data from their systems, what kind of speed is important when. For example, one of the things about photos is that a typical photo will get uploaded once and get seen tens or hundreds or thousands or millions of times. So because of that, it's not super important that it's quick to upload a photo. I mean, it's nice if they can process the photos quickly, but what's really important is they can retrieve the photos quickly, right? That's Facebook's critical concern. If a Facebook is going to be getting, viewed thousands of times for every time it gets uploaded, then obviously speed of retrieval is much more important. And they design their systems around that. Other topics, we'll talk about feed management, how they decide what to show you where and when in the feed, and then access and security. We'll have some other things. Amazon, of course, they do a lot of business, in case you haven't heard. So we'll talk about transaction processing for them. We'll also talk about recommender systems. Recommender systems are, for Amazon, for example, one of the ones you've surely seen is people who bought this also bought that, or people who looked at this product also looked at that. That's some information Amazon provides to you to make it easier for you to find relevant purchases. If you buy one thing, you might be interested in getting some add-ons. But recommender systems are everywhere. You could say even that Google is a kind of recommender system. You enter in some search terms, Google delivers, a bunch of search results that thinks, it's recommending to you as good matches for your search terms. And then, of course, various ways Amazon does cloud. In case you don't know, Amazon is the world's biggest public cloud service, so it's a natural point to bring on that. Google, of course, search, right? That's what everybody knows about Google. That's their main service they provide. We'll talk about indexing and retrieval. Obviously, in order to provide good search results, Google has to store information about, untold trillions of web pages and be able to retrieve it super fast. So we'll talk about that indexing and retrieval system, how it stores the page information and how it gets to it quickly. And then, of course, Google's bread and butter, advertising, around the order of $200 billion a year in advertising revenue. Finally, YouTube. Again, we have this, for YouTube, we'll have a lecture just generally about how the internet works. We'll also talk about quality of service. We'll talk about web apps. We'll talk about user-generated content, even things like about how much money you could expect to make off of YouTube if you became a YouTube superstar. I have a YouTube channel. I got like 200 subscribers on it, so that's, I'm well on my way. My son had a little window. So he's pretty good at Fortnite. He's not, the next ninja or anything, but he's pretty good for a kid. And he wanted to, start up a Fortnite channel. So he was going to show all his little friends in grade school, how good he was. It was kind of sad, though. It's a tough business. It was like, his friends were like, oh yeah, we'll come on at 5 o'clock, we'll all watch you, cool. And he was like, he got the streaming software that I got for him, got installed, got his little camera set up, and he was all ready, and nobody showed up, because, kids are assholes. So, anyway, he was kind of bummed about that, but he's over it. But anyway, who knows? Maybe anybody here make money on YouTube? No? Yeah. There was a great window like 10 years ago. We started seeing all these little just basic videos about like opening toys for toddlers, right? We had little kids at the time. Our son was born in 2011, daughter in 2015, and we were watching all these videos where it's just like some lady with crazy fingernails just saying, oh, let's see what's in this box. Oh, look, it's Peppa Pig. Oh, she's so awesome. And she made like $5 million a year doing that. So, yeah, right time, right place. Anyway, so this is the kind of stuff we'll talk about. All right, so last bits here. Online business principles, all right? So we covered all the lecture, covered all that stuff, and this is big picture stuff about online business. So online business has been going on for almost 30 years now as far as the internet. You could say that the internet kind of became a big thing around 94. It started to catch on to the broader public. So almost 30 years now, and we've seen a lot of stuff. 3 big principles, though. Number 1, domination by economies of scale. So that means as an operation gets bigger, it tends to dominate its competition. Just getting bigger is its own reward in a sense. Number 2, old products enable launching new ones. Businesses start out one line of products, but those products actually become the foundation for new products. It's not always seen in advance, but it does happen. And last, new technology disrupts industries. There used to be some industry that was all fine and everybody thought it was good, and then boom, some new technology comes along and suddenly all the old players, they're just gone. They're out of business pretty quick, and a new player that you never thought would be the big leader in that field suddenly takes over. So understanding that is really important for understanding online business generally. So, economies of scale first. So what economies of scale means is that as your production goes up, the cost of producing each unit of output goes down. So the way this typically happens is from distributing production costs over a larger number of units. So easy one to think about, manufacturing, right? So if you're making cars and you made one big assembly line, everything on that assembly line is presumably something you would need to make the first car, right? If you were just making one, you could have a guy do it by hand, but that's kind of silly. But suppose you were just making 1,000 cars, right? So you were at the point where making these cars by hand is no longer viable. You're doing too many. You do need some kind of assembly line process. Well, that assembly line hardware is really expensive, and if you distribute it only over 1,000 cars, every car is going to cost a lot of money. But if you make 1,000,000 cars with that one assembly line, then you're distributing the cost of that assembly line over 1,000,000 cars, and it becomes a fairly small share of that car's cost, right? That's what we mean when we say economies of scale. As production goes up, all these costs of production become less per unit of output, right? You can think about the same thing for hospitals, right? So if you're a hospital and you actually want to serve your patients with the expected range of things they're going to have, all this basic stuff, you're going to need all of that basic equipment on site, even though most of the time it might never get used, right? You're going to need all this hospital equipment because if somebody has a crisis, you need to help them out. But if you're a big hospital, then you can distribute those costs over more patients, right? And there's more chance over a given stretch of the day that that equipment will get used. So the average cost per patient go down. Now for online businesses, the same kind of thing. Businesses design what's called a platform. A platform is like a base system that serves as the foundation for various business activities. So example, Facebook, they have to have this platform that holds all the data about the feed and controls who can see what and how it gets delivered. That's the platform in that case for Facebook, right? And it costs a lot of money to build something like that. But a lot of the costs are in designing it in the first place and testing it, and as it gets bigger, it doesn't cost that much more to cover a lot more users. As Facebook adds more users, the cost of serving those users really goes down pretty fast. But what goes up, what is fairly linear, is the amount of money Facebook makes per customer. So as Facebook gets bigger, it's actually becoming more profitable. Anyway, other thing, return on optimization costs. So suppose you're Google, and Google is making in the ballpark something like $200 billion a year in revenue, right, from advertising. And suppose somebody else is Bing, and Bing is ballpark maybe making $10 billion a year from advertising revenue. Well, if you have some opportunity to spend $1 billion and make your platform work better, right, to deliver better ads to the right pairs of eyeballs so that they click on them and you make money, if it's a little optimization that costs $1 billion but will boost your revenues by 1%, for Google that's kind of a no-brainer. Google's going to look at that and say, yep, we'll make our money back in a few years, and then, you know, it's all profit after that. That's great. Bing is going to look at that and say, ooh, $1 billion, all right, take us like 10, 20 years to make that money back. I guess we're not going to do it. You know, they can see the value of it. It's just they're not big enough for that kind of cost to be worthwhile. All right, but there's more. There's more. One of the standard models of a network of users is that the value of the network tends to grow with the square of the number of users. And the reason is simply this. I'm going to draw it out as a set of lines. Okay. Imagine if these two pairs of lines represent all your users. Okay? Then every connection from, you know, one user to another, like this user is connected to all these, you know, this user is connected, you know, to all these other ones. You get the idea, mate. It's just hard to draw the lines because they all kind of. What's going to happen is as we fill in the set of all connections to all the other users, it's going to look something like a triangle, right? It's a sloppy triangle the way I've done it, but trust me, it's going to look like a triangle, okay? Something like that. And if we draw this line through there, that's why we say it's approximately n squared, because the area represented by the sum of all those lines is going to be, you know, half of a square, n squared over 2. So as n gets bigger, as you add more users, right, the stretch of all these connections keeps on getting bigger, fills about that shape, okay? So trust me when I say, you know, this is kind of a standard assumption in network design. If you're a networked business, getting more users creates more connections. Not all those connections are going to be valuable, but right off the bat, not all those connections were valuable either. But in general, the best guess is that, you know, the value of the network is going to be something like squared. Okay. Now, some real life examples, right, because that's a little bit abstract. Real life examples, eBay, right? eBay has a lot of sellers, right? There's a lot of people going to eBay to sell stuff out of their garage. Well, because eBay has more sellers, there's more product variety available. So the buyers go to eBay because they know that they'll see a lot of sellers there. They can probably find what they're looking for, regardless of what kind of oddball thing it is. Well, guess what? Because there are more buyers, more sellers keep coming back to eBay, right? Because it's a good place to sell stuff. So it's kind of a self-reinforcing effect. Same thing for Facebook. Facebook has had some threats over the years. You know, there was Google Plus for a while. There have been other social media things that tried to really make a big dent in Facebook. But at the end of the day, oh, just lately there was that Parler thing, right? But just lately, Facebook, you know, people are staying because their friends are staying, right? You go to Facebook and it's like, yeah, you have a bunch of photos up there, but if you wanted to, you could download them or you have them backed up somewhere else if they're important. But the reason why people stay on Facebook is because most of their friends are on there. And so, you know, that may be different for people. I hear, you know, Facebook is losing cachet among younger people, but, you know, still, there's going to be something up there, something else that becomes the next Facebook among the younger crowd. It's still going to be the same principle. You're going to be there because your friends are there. And of course, Google, right? Because Google, you know, provides high-quality search results for free. It gets more data to optimize its ads, right? There's a lot of eyeballs looking at search results on Google, seeing the ads on Google. Google has a pretty good idea of which ads are working and which ones aren't, so it's going to pick good ones. And because of that data, it can make more revenue per ad, which it can bring back into its system to keep on updating and optimizing its algorithms. All right. So that's economies of scale. Basically, as you get bigger, you get these advantages. Now, second thing. platforms enabling products. So a lot of the biggest online businesses lost money for years while building market share, right? Famously, Amazon lost money for, I believe, 17 years. At least on, on paper they were losing money, for accounting purposes. They didn't want to pay taxes earlier. They could have been profitable, on paper. But anyway, yeah, Amazon for a long time, on paper, they were losing money every year. Other companies, similar but not as dramatic. And the reason is they were all trying to build market share. If we follow from step one that economies of scale are important and you get them by getting big, then it makes sense to throw everything into keep on trying to get big before your competitors do, and it doesn't really matter if you're immediately profitable or not. So there are all these massive costs to develop these, world scale platforms, ones that were really, really big. But in every industry, the last firm standing tended to be dominant and safe from competition, right? If you're Google, nobody in the Western Hemisphere is seriously competing with Google for search, right? I mean, Bing is there, but Google kind of likes having Bing around because it's not a serious competitor and because it prevents antitrust legislation because it keeps Google from looking like a monopoly, Amazon is big. Nothing's really threatening Amazon as being the dominant retailer online or even really from being the dominant cloud provider, although there are stronger challenges there, right? YouTube is pretty safe as far as just videos because it has so much videos there. Lately, TikTok has become a thing. It's a little different. There's a challenge there. There's also a challenge to Facebook from TikTok, but it's a different challenge. So Facebook is pretty entrenched as, the big social media app. Where it's facing challenges is that users are drifting off to do things besides traditional social media. They're watching videos of TikTok with kids eating laundry pods or stuff like that, and whatever, but that means, eyeballs on TikTok are eyeballs not on Facebook. Anyway, but in a lot of cases, the technology that was needed to manage scale would lead to new products. So, for example, Amazon started out as a bookseller. As it dominated the book industry, what happened? It became a broad spectrum retailer. It started selling a lot of other stuff. First, commoditized goods, generic goods like books and DVDs and CDs, stuff like that, but eventually kind of branched out into everything. And then as it was having vendors sell their stuff through Amazon, and it needed to build all of these structures allowing vendors to sell through Amazon, at some point Amazon said, you know what? It really doesn't matter what kind of data we're managing. Sure, we're mostly managing vendors right now, but it could be anybody doing anything as long as we build up the interfaces for that. So that's how they got into cloud, and we'll talk more about that in Amazon. Likewise, Google, early on, free search, right? For quite a few years, Google was, free search without really running ads. It was a while before they started running ads along with search results. Anyway, the basic principle there, even though, over time the rate of people joining the internet has obviously been slowing. It wasn't like the 90s where it was doubling or more every year. It's now, basically in line with world population growth. And so if businesses want to keep growing, well, they got to figure out ways to sell new products on top of the ones they already have. They can't totally get rid of their brand. Facebook's not going to stop being social media. Google's not going to stop being affiliated with search. But they got to find ways to extract new revenue, by building on top of their existing platforms. Okay, last thing, disruption by new tech. All right, so anytime some new tech comes around, it creates this kind of potential for a revolution where suddenly whoever used to be strong in their field is now outdated. And this has been going on for basically all of our history. So in ancient times, once upon a time, you had copper as the dominant metal. So copper was something, they could find it in ancient Egypt, and it was nice because it was, you'd find it in a fairly pure form. It was easy to work. You could make weapons and tools out of it. But eventually somebody figured out that if you mix it with tin, and tin was hard to get. You had to travel to the other side of Europe to get it. It was in Wales or some in Central Europe. But, tin wasn't really anywhere near Egypt. But you could get bronze. And ancient Greece and some of these other places kind of being in the middle between those two things, they kind of had access to both. So that kind of launched in the Bronze Age. These nations that had bronze weapons were basically able to beat down the nations that had copper weapons. And then iron. Now, iron has the disadvantage that it rusts, sure. Bronze corrodes, but not nearly as dramatically as iron. But the nice thing about iron is it's pretty abundant. It's so abundant that it's pretty easy to make lots of farm tools and lots of weapons and armor out of it. And, Rome was the Iron Age. civilization that pretty much crushed all of the Bronze Age ones. You know, again, the big battle at that time was ancient Rome versus ancient Greece. But, you know, this is what happened. Same thing, 1850, trains were really new. Trains existed, but they were really new, running limited routes. So most of the time, if you wanted to get somewhere, you had to take a horse, or, you know, a carriage pulled by a horse or whatever, but you got a horse involved somehow. Then there were trains, right? There were trains and trolleys and trams and all those things, you know, mass transit. You can see the old-timey pictures of those. Like 1900, that was the way a lot of people got around. But by 1950, cars were the thing. And, you know, trains became associated with the Rust Belt. Now, these days, of course, there is commuter rail. I take Metro downtown every day, but still, you know, horses you don't see for transportation. Trains exist, but they're pretty limited. They're not like they used to be. Cars, trucks, you know, cars for getting around, trucks for shipping a lot of goods. That's mostly what you see. Now, of course, recent examples, you have Amazon replacing regular bookstores, you know, and of course dominating paper catalog competition. Facebook basically destroyed MySpace, which was the big social media before Facebook, and of course iPhones years ago replaced BlackBerries, replaced PDAs. So suddenly, boom, everybody wanted a smartphone in 2006, and they hadn't existed the year before. Near-term possibilities, number one, a lot of applications in the last 5 years have become obsolete by the new version of HTML. You know, all these Flash player applications kind of gone now. Google dominates search, but Google and Microsoft and other companies, they're all kind of chasing the spoken word technology to help control self-driving cars. Uber and Lyft, they're beating licensed taxis. How are self-driving cars going to affect their business model? And look in YouTube, right? Right now they're dealing with a major challenge from TikTok. How will that play out? Hard to know, right? New technology. Okay, this seems like an ideal break point since there's a minute left. If you got any questions, please look me up. But Thursday, we're going to cover the Facebook photo management lecture. Please read the lecture notes ahead of it. You'll get more out of the lecture if you do. All right.